Hello, my name is Ruffin, and in this lightning talk, I will be presenting our work on procedurally provisioned access control for robotic systems. We consider robotic middlewares, like ROS, where object types such as topics, services, parameters, etc. are organized under a namespace hierarchy. Subjects, depicted as nodes, representing servos, cameras, lidars, etc., intercommunicate within a peer-to-peer computation graph via standardized object APIs. Such subjects and objects may be distributed across a larger and more complex interconnected deployment example, as in the case of swarm robotic systems. To regulate and partition the data distribution throughout the entire system, an access control policy must be incorporated into the security transport protocol used by the middleware. To facilitate fine-grained access control, our contributions here are twofold. Firstly, we introduce ComArmor, a mandatory access control language akin to AppArmor that instead defines profiles for armoring computational graphs. Based on an extensible markup language, ComArmor can be used to compose hierarchical rules to bind allowed permissions between subjects and objects via regular expression attachments and recursive includes. Secondly, we introduce KeyMint, a meta-build tool akin to Catkin that instead compiles cryptographic artifacts for deploying secure ROS2 or DDS middlewares. By integrating ComArmor as a high-level intermediate representation of governance, users can procedurally provision access control for robotic systems while remaining agnostic to the transport specifics. For transport security verification, a subject-object bigraph, GS, is formulated from a deployment scenario, as shown here with a simple talker-listener example. Directional edges depict the respective allocated permissions, such as publish, subscribe, etc. We then extrapolate and deploy a fully connected bigraph, GTP, using the transport artifacts derived only from GS to provide an exhaustive test coverage scenario for each subject and object governed. Shown here is the relative intersective set of edges between the semantic graph representing the least privilege and fully connected graph used for test coverage. Experimental tests reveal vulnerabilities in ROS2 version ardent policy defaults as denoted by the false negative and positives found while benchmarking the transport implementation with our original intended security policy. In conclusion, we show how procedurally provisioned access control can be used to abstract the semantic profiles from the lower-level cryptographic artifacts, enable static verification and runtime policy testing, and lastly, to help discover security vulnerabilities in existing transport implementations. Thank you for your time.